All right, so on number one, it's the same paper from yesterday. You all have it, guys. Part F. We're going to skip over this. I'm not doing any of that. But I'm going to help you to decide whether you multiply or divide. And then you multiply or either you divide once I help you decide. Remember, you do the work on your own and just have it on Tuesday when you come in. So number one, it says a new frog exhibit at the zoo houses many types of frogs. One species from Cuba measures this many meters in length. And you can tell that species is very small because the exponent is negative. So it's a tiny frog. Another species from Africa measures this many meters, and it's also small because of the negative, maybe not as small as the other one. All right, about how many times larger is the frog from Africa? So we know the frog from Africa is larger than the frog from Cuba because it says how many times larger is the frog from Africa compared to the frog from Cuba. So this will be the larger frog, and this one will be the smaller frog. All right, so sometimes when things are in scientific notation, we have trouble understanding whether we add, subtract, multiply, divide, and with word problems. But you don't have to worry about addition and subtraction anyway. We haven't covered that. But if I break it down to just multiplication and division, sometimes we still have trouble. So I want you to think of something that is involves smaller numbers and regular numbers, something you're used to looking at, not scientific notation. All right, so think of this. You weigh 120 pounds. Your sister, who is only a few months old, is 20 pounds. So how many times larger are you than your baby sister? So you got to figure out how many 20s it would take to get to 120. It's 20, 40, 60, 80, 100, and then you would get to 120. That's 1, 2, 3, 4, 5, 6 times larger. It would take 6 of these to make 120 pounds. So you are 6 times larger than your baby sister. But to get 6 from 120 and 20, you would have to divide both of these numbers. And you would have to put the larger number first. And that will give you 6 times larger. So the same thing you applied for this is what you apply for number one. So if you divide to figure out how many times larger on this example, you're going to divide to figure out how many times larger on example one. So we should know anytime you see how many times larger, not how much more means subtract, but if it says how many times larger or how many times bigger is something than the other thing, that always means you're going to divide. Now, when you divide, guys, let me get rid of this. When you divide, make sure you put the larger number first. I just want to get rid of this portion. So if you look, and we're putting the larger number first, let's take a look at these numbers in scientific notation. The frog from Africa was larger, so the one from Africa is that many meters. Make sure you put that one on the top, okay? So it will look like this. And you can tell because -1 is larger than -2, okay? But remember, when you're dividing in scientific notation, you divide the numbers, but make sure you write a subtraction expression for these exponents. All right. Now, the one thing I'm going to ask you is to make sure that you write your answer in scientific notation and in standard form. So I want you to write it both ways. When I say standard form, I mean convert it to a regular number, guys. And remember to convert to a regular number. If the exponent is positive, the number gets bigger, so move right. If the exponent is negative, the number gets smaller, so move left, okay? When you're converting to a regular number. All right, let's take a look at number 2. You finish number 1. Make sure every time you do a problem, your answer is in scientific notation first, and then the answer is also in standard notation or written as a regular number, okay? All right, number 2 says the size of a bacterial cell is approximately this many millimeters. That's in length. The cell multiplies over time, and after 7 hours, there are about this many cells, which means there are about 1 million cells. If the cells were all, it should say lined up, guys. If the cells were all lined up in a row, what would be the approximate length of the row in terms of millimeters? So how long would it be? So I want you to think about this. The size of a small Twix bar is 3 inches. The little Twix bars that I might give you in my candy bag when you on my leaderboard or something. We'll say it's about 3 inches in length. If you line up 5 of those Twix bars, how long would the 5 Twix bars be in length altogether? So if you have one, it's 3 inches. You put another one with it, it's another 3 inches. Now I got to put 5 together. That's 4, and this one is 5. So this is me having 5 Twix bars all lined up of the length 3 inches. So how long is that altogether? 3, 6, 9, 12, and 15 inches. All right, so you could add 3 plus 3 plus 3 plus 3, 3 plus 3. But the easiest thing to do is 3 times 5 to get 15 inches. So you're going to do the same thing here. You're going to take the approximate length. You're going to take that length and you're going to multiply it by the number of cells. Like I took the length here and multiplied it by the number of Twix bars. So you're going to take the length here and you're going to multiply it by the number of cells. Okay, it's 1 times 10 to the 6 cells is 1,000,000 cells. So make sure on this one that you multiply. And remember, when you multiply numbers written in scientific notation, multiply the regular numbers, but then make sure you put a plus sign between the two exponents. So it's going to be -4 plus 6, and you tell me what that is. But make sure to write your answer in scientific notation and then put it in standard form, which is just a regular number, okay? Okay. All right, I'm going to let you try 3 on your own because 3 says how many times larger. And we've already looked at that. That's either like number 1 or number 2, okay? You figure out which one is pretty easy if you paid attention. All right, so you do number 3 on your own. Let's take a look at number 4. United States spends on average $10,200 on each student per year. So the government gives the schools money depending on the number of students that come to a school. That's how teachers get paid. That's how your administrators get paid. That's how things are purchased, books, because we are federally and state funded. All right, there are about 77 million students in the United States. So about how much money total is spent on students each year? Okay, so you're going to think of this. All right, you get paid $10 an hour, just like the school gets that much money for each student. And then you work 30 hours. So how much money would you make? So you get paid 10 every hour. You work for 30 hours. So you're going to get $10 30 times. So you multiply. Okay, that means that you would get paid $300 before taxes. So the same thing here. The school gets that much money for every student. Okay, so the schools, plural, because it's all the students in the United States, the schools would get this much money this many times, 77 million times. Okay, what I want you to do is make sure you convert these to scientific notation first, because we're going to multiply it in scientific notation first, and then we're going to convert it back to standard form. And if you tried to punch this in the calculator, I would know, because it won't even give you an answer. It's just going to be error. The number is going to be too big. So write them in scientific notation first. To write this in scientific notation, I'm going to move the decimal in between the 1 and the 0. So that's 1.02. You can drop those two zeros. Times 10 to the 1, 2, 3, fourth power. It's a positive 4 because this number does not begin with a 0. Okay? Then we're going to multiply by this number converted to scientific notation. I'm going to move the decimal between the two sevens. So that's going to be 7.7 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. So what you'll do is you'll go ahead and multiply your two numbers. You'll combine these two tens into one 10 by adding the exponents. Make sure your number is written in scientific notation. And then you can take that number in scientific notation and convert it to standard form for me, okay? All right, let's take a look at number 5. At the speed of light, which is 3 times 10 to the 8 meters per second, how many seconds will it take for the sun's light to travel this far, okay? So this is speed, guys. So the speed of light is this fast. It can go that many meters per second. And a meter is, so imagine a meter being like from the floor to my doorknob in my classroom, up to the doorknob. That's about the length of a meter from the floor up to the door handle, okay? So it can go this many of those lengths every second, which is a lot, because 6 zeros would just be a million. That's 8 zeros, okay? But it can travel that fast in 1 second. So light travels pretty fast. All right, so how long would it take for light to travel that many meters in all? All right, so imagine this. Think of this. You're traveling to your favorite destination and you travel at 60 miles per hour. So that's your speed. How long will it take you to travel 240 miles? That is your distance. So how long would it take you if you're going 60 miles every hour to get 240 miles? Well, after 1 hour, it'll be 60 miles. After another hour, it'll be another 60, which will put you at 120 miles. A third hour, you'll have gone another 60 miles, which will put you at 180. And after another hour, you will have gone another 60, which will put you at 240 miles. That will take a total of 4 hours. But what do you do with 240 and 60 to get a 4? Well, you divide. So you're going to divide what? Well, so I took the distance, which is 240. All right. And then I divided it by 60, which is speed. And it will give you the number of hours, which is 4. So you're going to do the same thing here. You're going to take your distance that you're traveling. So you need to travel this distance. That's your distance. You're going to make sure you take your distance, which is 1.5 times 10 to the 11th meters. And you're going to divide it by the speed, which is 3 times 10 to the 8th meters. All right, make sure you write your answer in scientific notation. And you write your answer in standard form. So write it in scientific notation first, and then you can convert it to standard form. All right, guys. Have this by Tuesday when you come in. And be careful over the little break.